Hello, my name is William Sweet. I'm an oceanographer for the National Oceanic and Atmospheric Administration, or NOAA. Today, I'm going to talk to you about sea level rise, the impacts here and now. So let's just start with some of the recent news. The Intergovernmental Panel on Climate Change, or the IPCC, just released a report, the sixth assessment, that really had some superlatives that were brought to attention. Um, CO2 concentration is at the highest of last 2 million years. Sea level rise is the fastest in the last 3,000. Arctic sea ice from warming oceans is lowest in the last 1,000 years. The glaciers are retreating at unprecedented rates in the at least last 2,000 years. You know, if Bob Dylan was singing a song and it might have been on the B-side hit, the tides there are changing. And yes, indeed, they are in response to these global changes that are occurring. We are seeing local impacts due to rising seas, and this is becoming a challenge and a problem. And this is largely what we'll focus on in today's talk. Part of the motivation of this study and our focus at NOAA is recognizing that there have been repetitive claims, let's say, in the National Flood Insurance Program, not just from sea level rise. This is storms, it could be interior, but if you see along the coast, we are starting to experience repetitive losses, and we're starting to witness and observe repetitive flooding due to a variety of reasons. And this is the new norm, and this is something we should expect moving forward in a changing climate with rising seas. So let's take a look at sea level itself. We measure it from many places. Shown on the right here is the global map showing that sea levels are not rising uniformly like they would in a bathtub. We have rates that are higher, let's say on the east and Gulf Coast, upwards of 4 or 5 millimeters a year of ocean rise. That's about an inch every 5 or 6 years over the last several decades. This is due in large part due to two main reasons. We're having ice melt in Greenland and Antarctica and mountain glaciers. Shown here on the left is the amount of ice that's been lost at Greenland over the last 1 to 2 decades. So as ice melts, it raises the level of the ocean. Steric height, or thermal expansion, the heating, as the ocean warms due to atmospheric warming, it expands. And here's a rate of change that our colleagues at NASA and NOAA have been monitoring. So it's ice melt, you have additional mass into the ocean, but then the ocean is warming and it expands. And so we see together that rate is largely a combination of the two, which we highlight at the bottom. As the amount of ocean mass increases and it expands, those two summed together equals pretty much on a global average how much sea levels have been rising over the last several decades. About an inch every 8 years on average, but we know, again, it's not like water rising in a bathtub. So quickly, why is it rising? Well, we talked about the thermal expansion. That's about one part. The other two parts are the contribution of land-based ice, the melting of Antarctica, Greenland, mountain glaciers. There's a little bit of variability associated with land storage, whether we're creating dams as we did in the 40s, 50s, and 60s, or now it's pumping of groundwater. Water used to be in ground, now is being pumped up, used, and it's flowing into the ocean. So there's a marginal contribution from the land storage of water. But as we notice how patterns of sea level have, as shown in the earlier slide, as well as looking forward in time, we know that there will be other reasons why water sea level will not rise like it is in the bathtub. Vertical land motion, whether it's natural or unnatural reasons, such as natural would be compaction of sediments or an adjustment from the last ice age. Unnatural would be pumping of water for drinking, groundwater from drinking, or fossil fuel for consumption. Whenever you extract a fluid, the land will compact and sink. But we also know that dynamical changes in Gulf Stream, for instance, changes in circulation will have an effect, as well as where ice melts really does matter. If you're close to a source of a tremendous amount of mass, it actually will affect the gravitational tug in that part of the world. So as you lose ice, the gravitational tug decreases some, and it affects sort of the displacement or where that water will find a new equilibrium. Sounds esoteric, but it's important to recognize because decisions are made locally. We want to give projections as locally as possible, understand the rate of change in the past, as well as giving projections of the future so communities can plan and understand. So in short, there's a lot of things that matter. Where ice melts matters, the Gulf Stream matters, what we mine from underground matters, really in terms of future sea level, past and future, I should say. So when we look at it at the United States level, we've noticed, based upon our long-term measurements of NOAA tide gauges, that we have over 100, upwards of 200 or so along the coast, including the Great Lakes, that have been there to measure sort of for safe shipping, high tide, low tide, when to bring the ships in. But they're also telling a story that sea levels are on the rise. Tides are rising higher. Storms are now impacting that much higher due to sea level. On average, in the last 100 years, sea levels have risen, relative sea levels have risen about a foot in the last 100 years. And that rate has been increasing over the last 50 years. And so the question is where are we headed in terms of future sea level rise? We know that because of sea level rise, the risk of flooding has increased. And so here we show a schematic from Norfolk, Virginia, showing 5-year snippets of the daily highest water levels over 5 years relative to our vulnerabilities today. So this is when minor flooding would occur at this red line, and we will just sort of play the tape and fast forward. And there are storms, there are big hurricanes that will happen in this part of the world. But in general, there's a garden variety of reasons why communities are starting to flood more often, as the gap between our infrastructure and typical high tide closes. Changes in prevailing winds or strengthening or slowdown of an ocean current like the Gulf Stream is now sufficient enough to cause flooding. You throw in a full moon and all bets are off. We're flooding more often than we used to. And that's just the facts of the data speaking. But we are also having evidence on land of people witnessing and experiencing this. And this is where we're putting the two together of the physical data with the humanistic understanding and experiences of this flooding. So if we think about this as a typical bell-shaped curve that maybe we all were graded on in school, we can look at it in this it's the same data, just sort of showing sort of a bell-shaped sort of risk curve. 365 days are represented under this curve, and on the x-axis is height above mean high water, or typical high tide. So 0.5 meters or so above high tide, that's a 1.5 feet or so, almost 2 feet. You can see it's sort of rare. Water usually doesn't get too much lower. It's sort of within a typical zone that your high tides typically hit. But due to sea level rise, they're inching up, and that sea level rise, storms happen year to year, but the tides are rising higher. And what is starting to run amok is that we have our infrastructure where it is. And so we're getting to the point that major flooding is more likely now, but it's still very rare. And so it's not something that's happening every year. It's not as noticeable. But the minor flooding, disruptive flooding, flooding in the streets is now becoming sufficient enough. It's getting very close to that nonlinear, that fat of the curve. And so what this means is we're starting to see this on an annual basis, multiple times a year, and those increases are really starting to jump up. And when I say that, here would be an example. So if we looked at the nation as a whole, again, an average, that same blue line, a foot of sea level rise in the last 100 years, the average number at about 100 tide gauge locations with these minor flood thresholds, water in the street, water coming over seawalls, water bubbling out through stormwater systems and out on the street, affecting people's property, affecting commerce. We're starting to see a real uptick in the number of days per year. In fact, it's 2 or 3 times more often in the last 30 years. Not cherry picking data, but if you'd fit a trend line, you could see that the data is it's happening more often. Flooding is happening more often due to sea level rise, and that is the new norm. And so we're making products and we're keeping track of this at NOAA. So we can show mapped layers, such as shown here at the NOAA Sea Level Rise Viewer, that shows the extent of land that's at or below this minor flood threshold. And here would be an example from sort of the Miami area showing how these counts have really been jumping, where 20, 30 years ago, you just wouldn't have flooded unless it was a hurricane or a very strong storm. But now the numbers are really starting to jump up. There is some year-to-year variability. Not every year is the same, but the trends are that, the flooding, chronic flooding is becoming the new normal. And so once these types of flood impacts are noticeable, water in the streets, water come up, stormwater systems, it means that this type of problem is going to go chronic rather quickly. It's not going to be a slow, gradual change. We're having an acceleration in the number of days with flooding due to sea level rise butting up against where our infrastructure is. So to communicate this, I've shown an example of red, sort of the minor, which is showed red because it's flooded. Whenever you have a moderate, major flood, a bigger flood, the red's always being flooded. So sort of red is the frequency kind of color. But on average, around the country, minor flooding happens at about 2 feet above high tide, moderate flooding about 3 feet, major flooding about 4 feet. It varies some by location. But these are tuned to weather forecasting. So if a big event's coming or a small event's coming, the Weather Service, in conjunction with emergency managers, will alert the public saying, flooding is likely in the next day or so. Take preparations now. So we're using thresholds that really communicate sort of threats to people, so they can really understand it in terms of, do I bring boots to work today, or do I evacuate because of a hurricane? We're really trying to graduate, let's say, risk within the FEMA floodplain of, the 1% annual flood risk, which usually would happen in a very big storm versus a little storm. But let's start graduating risk and starting to communicate, what is the likelihood of these types of floods now? How has it changed in the past? And what's it likely to be in the future? So that we can really sort of have a climate weather story. It's things that are evolving every day in front of us, but climatically they're becoming more likely. And this is the type of information we're trying to package up and deliver to the American public. So again, we're making maps showing these 3 layers, minor, moderate, major. So they're just different elevations. So the major would be upwards of 4 feet, moderate up to 3 feet, minor up to about 2 feet. And here would be an example from Charleston, an example from West Palm Beach. So again, elevation matters. You're at higher elevation, you're less likely to flood. But what is your overall flood risk? Can we give some better inferences as to what the risk is today and what's it likely to be in the coming future? So again, starting with sort of what's happening now, we have an inundation dashboard that really has all these tide gauges I was making a reference to around the country, and they'll blink if you're flooding or likely to flood. And here's an example of Annapolis, Maryland, where I own a home and have lived many years and sailed the bay. The sort of the cyan colored blue is what's likely to unfold. And this was a few months ago, gave a talk. But you can see once you start hitting the minor flood level, this is the community I live in. I'm lucky enough that the impacts are, maybe the pier goes underwater, the fire pit is jeopardized. But downtown Annapolis, it's a very different story. Water's up to the storefronts. People aren't shopping. Businesses are losing money. People's commute paths are being adjusted. The U.S. Naval Academy's there, and they're having issues. So it's really, it's affecting all sorts of society, whether it's commerce, commutes. It's weighing on people's patience. It's sea level rise that's starting to happen more often when it's sunny outside because of decades worth of sea level rise. So we're giving products now that can alert people and understand what their flood risk is now, what's it likely to be in a day or two from now, but we want to project into the future to give actionable information. And so to do this, I'll pull from a recent interagency sea level rise working group that I'm co-lead of, and it represents many of our U.S. federal agencies. And we recently put out a report that really was trying to answer 3 things. One is, how much sea level rise is likely in the next 30 years? That's an important time horizon. It's a mortgage, but it's the type of time horizon that really will motivate a lot of people's decision. But how much could sea level rise by the end of the century or beyond? Not just what's most likely, but what is potentially likely, what's plausible, because lots of types of decisions need to know about the low probability but high impact outcome. nuclear power plants, new infrastructure, important fire stations, school. We don't want to build these in harm's way. So we need to really make sure we give a very clear understanding as what the goalposts are at the end of the century. But the third part is, can we contextualize that? What does a change in mean sea level really mean to us at the ground in terms of flooding, storms, and tides? How much higher will they reach and what will they impact? And so again, putting that context of, well, we've risen about a foot in the last 100 years over the United States. When we look at the trajectory of these tide gauge observations, which are shown in black, and we stack them up to our 5 scenarios of future sea level rise. And I'll talk about those in a moment. Somewhere between a foot and over 6 feet or so on a global average, downscaled here shown locally. The trajectory and the modeled scenarios all squarely overlap. And there's not much deviation between these modeled scenarios over the next 30 years. So what this means is they're emission-based, more or less, based upon different amount of warming, is we have a certain trajectory or momentum into the system now, such that we have very high confidence as to how much sea level rise is likely to occur. We're not talking uncertainty, we're talking more about certainty, and with clarity and consensus amongst the federal government to say, on average, we're expecting about a foot of sea level rise in the next 30 years. That matches the amount that's occurred over the last 100. But again, we know it's not going to be like water in a bathtub. There are reasons why certain areas will be higher or lower than that 1 foot, for instance. So we know there's a difference between the East Coast and the West Coast. Part of that's because vertical land motion. Much of the East and Gulf Coast is sinking due to adjustment from the last ice age, compaction of sediments in the Mississippi River Delta, extraction of fresh water and fossil fuel for consumption is a big part. But we also know dynamically heating is not the same. The warmer waters of the East and Gulf Coast are expanding quicker than they are in the West. It's colder. And so there are differences, and it's important to get these nuances right in our projections. So again, planning is made at a very local level, and we need to adjust sort of the global national numbers to a local level. Again, where Antarctica versus Greenland, where ice melts matters because Antarctica will have an amplifying effect over the whole United States, whereas Greenland will have a differential effect. If you're close to Greenland and it melts, you may not feel that whole extent of the melt. Again, these are things that are built into these scenarios, so we don't make folks have to do these computations themselves. We just let them know what's in it, what went into the ingredients went into the dinner, and we're going to serve it. And so when we look regionally around the United States, these are the numbers that we expect over the next 30 years. So there is some range, right? A foot, foot and a half over the East and Gulf Coast, less on the West Coast, for those very same reasons I showed in that earlier snapshot from slide before at 2050. So here's some takeaway numbers. Take these to the bank. Sea level is probably not going to rise less than these numbers. It could be more, but these are pretty solid numbers for the next 30 years. So with that, what does that look like? What does that mean? We know that the effects of sea level rise are already occurring. Sea level rise flooding, high tide flooding is now 2 to 3 times more likely than it was 30 years ago. What does that look like? Well, this is Norfolk. This is Charleston. This is Miami region. Sunny outside, it's flooding, there's water in the streets. This is the effect of sea level rise. It's here, it's now. It's not an end of the century discussion any longer. With that in mind, it's important to recognize that the impacts are here, and they're going to get worse with future sea level rise unless we do something about it. And so what does that look like in the next 30 years in terms of ocean flood probabilities unless we do something about it? Increase our flood defenses, mitigate against these impacts, whether it means fortifying, if it means relocating, or if it just means building in a smarter way so that we can learn to live with higher seas. What we're expecting is a flood regime shift. So earlier, the minor flooding is 2 feet. The moderate flooding is 3 feet. The major flooding is 4 feet above high tide. So if sea levels are going to rise about a foot on average around the country, well, then we have a flood regime shift. What used to be minor flooding will become moderate, or the frequency of moderate flooding will take on the frequency of minor flooding today. Moderate and major flooding is damaging and outright destructive, whereas minor is disruptive. So moderate flooding is projected to take on the frequency, or even more so than minor. Damaging flooding will become the new normal. So what does this look like? And I should stress, without action. We will find a way to engineer and develop the capability to deal with this water so that we don't have these impacts. But this is our footprint as it exists today. And here would be a snapshot of Charleston, South Carolina. And so today, around 2020, here are the flood frequencies for the minor, moderate, major. Minors happening 2 to 5 events per year, a couple days per event, so somewhere between 5 and 10 days per year. Moderate, 0.2 events per year. So that means about every 5 years on average. By 2050, moderate floodings happen 5 events per year. Minor is just 40 events per year. We're getting close to high tide. Major flooding is happening sort of in a 20% annual chance, or every 5 years. So again, the extent of land that's exposed to flooding due to sea level rise is going to increase, and the frequency of that flooding affecting these areas is really going to jump. So we need to be prepared and plan so that we can mitigate against the impacts and keep our footprint where it is, and our way of lives can still maintain what we enjoy and appreciate at the coast, knowing what's coming. And so pictures do 1,000 words. This would be Norfolk. This is a moderate level flood. This is the type of flood that really obstructs access to the naval base, the largest naval base in the world in Norfolk. So 1990 would happen about every 5 years, or a 20% annual chance in a given year. But due to sea level rise, now about an event every year. And in 2050, which is in our headlights, we're talking 5 to 10 events per year. Change is on its way. Change is happening now. We give this information so folks can plan and prepare. It's not to scare. It's to get us ready for change and make sure that we are adapting and mitigating our way into a future where waters are higher. But again, a flood's only a flood if it floods. A high water level might not be that impacting as long as it's not flooding. So to conclude, nationally, sea levels are headed for about a foot rise in 2050, or the next 30 years. Without action, and I need to stress that, unless we can do things, but if we don't, a flood regime shift is to be expected, because there's only about a foot between these 3 flood categories around the country. Emissions matter. Beyond 2050, which I didn't really talk about that much, we're already sort of set for about 2 feet of rise along the United States coastline by 2100 emissions to date. It could be much higher. And beyond 2100, the numbers do get higher. But one thing is for certain, less emissions equals a greater chance for less sea level rise. See, as emissions go up, ocean and atmospheric heating increase, ice melt increases, thermal expansion increases, sea level increases, flood risk increases. Less emissions equals lower flood risk in the future. Elevation matters. Lower elevations are just at greater risk in general. We know that flood risk is not the same around the country from those maps I just showed, but in general, when there's a chance to relocate or to develop new infrastructure, major infrastructure, remember, elevation matters. Use the maps to figure out where higher elevations are, and those will be areas that will be less susceptible to flooding. And what I've spoken about today is really from ocean-related flooding, land subsiding, ocean waves, tides, storms, you name it. But it has not factored in heavier rains, which are becoming more prominent with warmer atmosphere, stronger storms that we're starting to bear witness to, let's say in terms of hurricanes, and rising groundwater tables. As sea levels rise, so will the groundwater. All these will further compound risk and increase risk at the coast. So I'm happy to entertain any questions. This presentation is not to be sort of doom and gloom. It's really meant to open folks' eyes and alert them to change that's already occurring and what's likely to continue to change. We have a website at NOAA that we have compiled a lot of NOAA maps and data and models and lots of things that describe change at hand and what's likely to occur. We also include some other interagency tools and services as well. So I highly recommend that you check this out. If you have any additional questions, please contact me, William Sweet with NOAA. Thank you very much.